In this order, we are told we need to administer amoxicillin via oral suspension, 250 milligrams by mouth, every 8 hours, and this is for an infection. We go to the label and we see the label provides us the following information. We're told to add 50 mLs of water and shake vigorously, so we're going to be doing that to the container. And each 5 milliliters will contain equivalent to 125 milligrams of amoxicillin. This is a reconstitution problem. And when we say reconstitution, that means there's some work to do before we can go and just administer the medication. If you think about capsules or tablets in a bottle or pill bottle, you go and you give those to the patient. They're ready to go. Oftentimes, especially with oral suspensions and also for injections, the drug is in a powdered form, but it needs to be turned into a liquid form. And as I've already mentioned in the module, when I think of reconstitution, I think of hot chocolate. And you take the powdered form, you mix it in the water or the milk, and it becomes a liquid, and you drink. So this reconstitution in these situations are very similar, where we're adding some sort of solvent, we're mixing it together, and it's producing the medication that we will be administering. Now, what's tricky about this problem is oftentimes, especially with the calculations, we're given more information than we actually need. And anything involving the instructions for mixing are not necessarily important to us when we are trying to just calculate how much to give. It's obviously important when you're preparing the drug. So right here, this part, add 50 mLs of water and shake vigorously. That's obviously incredibly important when you're preparing the drug. But for making the calculation, this 50 mLs is really not necessary. And in fact, I can tell when students are confused about these problems because they will incorporate 50 ml, they'll incorporate 50 ml into the calculation. This is just important for the mixing. What we need to know, and the most important part of these problems, is to look for information about the dosage strength. And oftentimes, you're told, add 50 mLs and it will yield, so it will yield or will provide you. These are phrases to look for, because when you look for these phrases, they're about to tell you the strength of the drug. And we know the strength is just a ratio, in this case, of milligrams to milliliters. And we're told each 5 mLs will contain equivalent to 125 milligrams of amoxicillin. So the strength of the drug is 125 milligrams per 5 mLs. That is the information that is most important in this problem because it tells us the strength of the drug. So once we know that, we can solve and calculate how much we need to administer. And we can do that in a number of different ways. If we were to use dimensional analysis, we know we start with what needs to happen. We need to give 250 mgs. And when we're done with our calculations, we know we're going to be physically administering an amount of mLs. So I will start by writing 250 mgs over 1. And I have my conversion factor from mg, milligrams to milliliters. There are 125 milligrams for every 5 milliliters. So this is just using the dimensional analysis, and the milligrams will cancel. I will be left with 250 times 5 divided by 125. This is going to be 10, so 10 milliliters. You could also set this up using a proportion. So we know the strength of the drug. This is the relationship between the weight of the drug, or the mass, the milligrams, per mLs, and this is an invariant relationship that will hold as the strength. So if we were to look for an equivalent number of mLs, we don't know the mLs for 250 milligrams. We can solve this using a number of different ways. Cross multiplication is one, or we could look to see, well, I noticed that the milligrams are increasing by a factor of 2. That's telling me the milliliters needs to increase by a factor of 2. 5 times 2 is 10, so 10 mLs. So just again, very briefly, we see here we're given more information in reconstitution problems that are needed for the calculation. 50 mLs did not fall into any of these calculations. It's important for mixing the drug, but anything that is typically anything involved with mixing the drug, 50 mLs, 5 mLs, whatever the case may be, the mixing of the drug is not going to be important for calculations. Look for phrases like it yields or it will provide you, because they're probably going to tell you the strength of the drug. That's what you need. What's the concentration or the strength of the drug?